Hi, my name is James Vaughn, and this is my presentation for CS6460. I created content as part of this class. It's a primer on computer science topics. The motivation for this came from work I do as a mentor for a local coding boot camp. Many of the students there will ask what's missing in their education. They've learned to be software developers, but they don't have a strong computer science background, and so these lessons are to help start teaching some of the computer science topics that they don't get to cover as part of their curriculum at the coding boot camp. I've created 5 lessons in total to date. I do plan on going further, but for now I have a lesson on big O notation, a lesson on sorting, a lesson on searching, a lesson on recursion, and the final one is on data structures. They are delivered via Jupyter Notebooks, and there's a repository that is open source and hosted on GitHub that students can clone and then go through the notebooks on their own. In the repository there is a README that talks about kind of the background of this and then how to get set up and start running. I have created a getter for social interaction in case there are questions to be asked and answered, and there's also a wiki where students can go and learn more about the project itself. So I will show you now. I already have Jupyter up and running. The way that this is structured, the folders that have the lesson names are supplementary to the notebooks themselves. So for example, in lesson 2 you will see a main that has questions that can be answered from the notebook, and they come back to main, and then also examples in case the students get stuck. They will be able to import examples of how to solve the problem at hand. So as I said, the first lesson is on big O notation, and the way all the lessons work is they start with an import of main, which allows then for answers to go back and be checked based on the question that's being asked. So you can get a feel for how the notebooks are laid out. There's description, and then a test, or not even a test, a quiz, and then in some cases there will be places for students to actually enter code so that they can try to implement some of the algorithms that are being taught. I will show you how this lesson works. So we'll import main, and then in order to answer this question I need to choose one of the answers from the list. So I'm going to say that answer is B, and you see that I get a hint that talks about this is not the correct answer and what needs to or what the student should consider before trying to answer again. So we'll change the answer to C, and we've answered the question correctly. I also included a small chart that shows the difference between O of n and O of n squared as n increases. O of n does not increase it anywhere near as dramatically, obviously, as O of n squared. All right. So lesson 2 talks about sorting, and the lessons on algorithms include pseudocode in addition to the opportunity for students to actually implement the algorithms. So this lesson includes bubble sort, insertion sort, merge sort, quick sort, and selection sort. In addition to having an opportunity for the students to implement the algorithms, we do revisit big O notation and let the students understand the differences in these algorithms as to what the impact is on complexity and or relative execution times. If a student were to get stuck, I also have examples of each type of algorithm. So by creating a new cell and pasting in the code that's listed for the example, when they execute that, then they will get an example implementation of that algorithm. Lesson 2 is similar to, or Lesson 3 is similar to Lesson 2. It is a lesson on searching algorithms. And in this lesson, I covered binary search, indexed search, sequential search, and provide a link to a tree search that was a little bit deeper topic than I could go through in that particular lesson, and it would require some understanding of a tree data structure, which has not been covered at this point. I will say that the lessons do not necessarily have to go in order. I laid them out in the order that they're in because that to me made more sense, but obviously the students can go in whatever order they want since there's nothing that directs them from one to the other necessarily. Lesson 4 covers recursion. And here we talk about how to implement factorial, Fibonacci, and we revisit the quicksort using recursion instead of looping. But the examples here show loops as well as recursion on how the algorithms could be solved. And again, there are examples where students, if they get stuck, can look at the example and then see how the algorithm is implemented. And finally, Lesson 5 covers data structures. There is pseudocode and a description of the interfaces for various data structures. In this lesson, I covered linked lists, stacks, queues, and trees. So the normal methods and operations that are available on some of those data structures are covered. For example, in the stack, I talked about pushing, popping, peaking, and queues to NQ, DQ, and peak, and then give the students an opportunity to implement the data structures on their own. And again, if they get stuck, there is an example of a stack, an example of a queue that they can look at to see how that implementation should work. The hope is that long term, the lessons will grow, increase in number, and increase in quality as well. I look for feedback from people who take the time to run the notebooks, make suggestions on how the lesson could be improved, what content they feel is missing. At some point, it might even be possible that someone could create their own lesson and submit that into the repository to be included as part of this. This project was a lot of fun. I thank you for taking the time to watch my video. And if you get a chance to check it out, please do. It's at github.com/jimv3/CSP. Thanks.